We are on page 379, lesson 7.4, rational exponents, when your exponents are fractions. I'm going to start with 125 to the 1/3 power. 125 to the 1/3 power. They want you to simplify this. So they want you to give them the answer. When they're asking for 125 to the 1/3 power, you have two parts to your exponent, and each part has a very special place that it goes. 125 to the first power, and you're taking the cube root. That's what that means. So what is the answer to 125 to the 3rd power? To the 3rd root. What's the 3rd root of 125? What's its cube root? 5. Okay. 5 to the 1/2 times 5 to the 1/2. Now there's two ways you can look at this problem. What have we taught you to do with your exponents if your bases are the same? If you have the very same base, what do you do with your exponents? You can add them, subtract them, multiply them, or divide them. It's one of those four. Which one do you think? Add them. If you add them together, what's 1/2 plus 1/2? 1. So the answer is just 5. Now, if you want to work it the other way, no, you do not multiply the 5. If the bases are the same, you add the exponents, but you do not multiply their bases together. This could be 5 to the first power, and you're taking the second root. 5 to the first power, and you're taking the second root. So you're taking the square root of 5 times the square root of 5, which is the square root of 25, which is 5. So it doesn't matter to me whether you work it this way or this way. 10 to the 1/3 times 100 to the 1/3. Okay? That is the cube root of 10 times the cube root of 100. I cannot take the cube root of either one of those. But since I'm trying to take the very same root, you can multiply the numbers together. What is 10 times 100? And what's the answer to the cube root of 1,000? 10. Okay. Okay. 16 to the 1/4 power means that you are taking the 4th root of 16. What is the 4th root of 16? 2. 2 to the 1/2 times 2 to the 1/2 means you are taking the square root of 2 times the square root of 2, which is the square root of 4. And what is that answer? 2. 2 to the 1/2 times 8 to the 1/2 means you're taking the square root of 2 times the square root of 8. That is the square root of 16. And what is that answer? 4.
Where'd you get the 8 from?
Right there. It was in the problem.
When you multiply the same number with the same exponent, was it always just over?
If they're taking the square root, okay? If they're taking the square root, that'll always work. Okay. Next set of examples says write the exponential expressions in radical form. So they're going to give you this form, and they're going to want you to write it as a radical. And then in a few minutes, they're going to give you the radical, and they're going to want you to write it in exponential form. So here's what you need to remember. You need to remember that there's a radical, x is under the radical, and there's two positions. There's the root, and there's the power. The denominator tells you what root you're taking, and the numerator is your power. Sometimes you will see this written as the fifth root of x all cubed. They mean the same thing. Y to the negative 2.5 power. You have to write 2.5 as a fraction so that you can have a number in the corner of your square root and a number as a power. So what does 2.5 look like as a fraction? Negative 5 over 2. So this is y to the negative 5 over 2. Now what about that negative exponent? The negative part of the exponent tells me that that whole piece needs to be moved to the other part of the fraction. Okay? The negative part of the exponent tells me to move it to the other part of the fraction. Now I have to change that rational exponent into a radical. So it is the square root of y to the fifth. I know that you can simplify it, and I know that you're not supposed to leave a radical in the denominator, but for this problem, all they're wanting you to do is convert, so they're going to let you leave your answer like that. But just know that really there's a couple of more things that need to be done there. Okay, so what if I gave you this? A to the third under the square root, and I want you to write it with a rational exponent. Sometimes it's like this, it's going to help you if you'll go ahead and put what root are we taking in the corner. When there's nothing there, what's really there? A 2. So this is a to some power. What power would that be? Got the other way around. 3 over 2. The number that's in the corner, Chanel, right here, is going to go on the bottom.
Oh,
okay. What about this one? The fifth root of b all squared. What's that one going to be? b to the 2 over 5. Okay, what if we have y to the negative 3/8 and we want to write it as a radical? What do? The negative causes it to be in the bottom of the fraction. Okay. What about z to the 0.4 power? Well, you've got to change 0.4 to a fraction. What's that going to be? 4/10. So this is the 10th root of z to the 4th. Everybody think they got it? Okay. Example 4, negative 32 to the 3/5 power. Write it as a radical. What goes in the corner? 5. What goes underneath? Negative 32 to the 3rd power. Negative 32. Can it be written as something to the 5th power? Two to the 5th power? Because the way I've got this written, what is negative 32 to the 3rd? That's the fifth root of 32,768. Now you can do that on your calculator. And you're going to get what for an answer? 8. But you come back over here. Let's look at this from a different perspective. We could write this as negative 2 to the 5th, then raise it to the 3/5 power. Okay? Negative 32 is actually negative 2 to the 5th. What would happen to those exponents? When you have one base and two exponents, you're supposed to do what? Let's just say we had x squared cubed. What would that really be, guys? 6. You multiply them. You get x to the 6th. So we're going to do the same thing here. We're going to multiply those exponents. Well, if you multiply 5 times 3/5, what do you get? Five over 1 times 3 over 5. Your 5s are going to cancel, and you're going to get negative 2 cubed, which is what? Negative 8. That one should have had a negative 2. Okay?
I understand how negative 32 is the same as negative.
It's not negative 2. It's negative 2 to the 5th. Lexi, tell me what this is. Let's figure this out, okay? What is negative 2 times negative 2? No, it's positive 4. What is negative 2 times negative 2? Okay. And then I still have that one over there, right? What's 4 times 4? Okay. What's 16 times negative 2? Negative 32. Sometimes you just have to look at it that way for it to click, though. Okay, let's do another one. 4 to the negative 3.5 power. We'll change negative 3.5 into a fraction. What is that? Negative 7 over 2. Write 4 as a power of 2. 4 is equal to 2 to the... Look here. Here's what I'm talking about. 2 to some power is equal to 4. 2 to the second. Okay. Now you need to multiply 2 times negative 7 over 2. What happens when you do that? Those parts cancel. 2 to the negative 7 power. Now why is it a negative? What does that negative tell me I need to do? The negative part of the exponent tells me to move it to the bottom. And 2 to the 7th is what? 128. 25 to the negative 3 over 2 power. Write 25 as a power of 5. It's 5 to what power? 25 is 5 to the second power, and then we're going to multiply it by negative 3 over 2. The 2's are going to cancel, and I get 5 to the negative 3. The negative part of that exponent tells me to move it to the bottom, and then it's 125. 32 to the 3/5. You're going to have to write 32 as something to some power. Who remembers what it is? We just used it up here. Well, we used negative 2, but it's the same. We'll have the same exponent. How many times do you multiply the number 2 together to get 32? 5. Okay, 32 has to be broken down into something to some power, okay? Well, that's all. 4 won't work, and 3 won't work, and that's the only number it will be. You need to be able to look at these numbers and say, oh, that is a repeated multiplication of something. For example, 125 makes you think of what number? 5. And if I were using 81, what would you try to write it as? 9, but what could you really go even lower? 3. 3 to some power. So we're not necessarily picking out square roots anymore. We're picking out numbers. We're changing it to something with a base and an exponent. Now, every single time we've worked this, what's happened here? Has that happened? Okay, so that kind of is a clue for something you should try. Okay, you kind of see the pattern happening here. So 2 to the third power is 8. Negative 32 to the 4/5. Well, what about negative 32, y'all? It's negative 2 to the what power? 5th. And then all that's raised to the 4/5. Pretty much. So we're going to get negative 2 to the 4th. And what is that? What's negative 2 to the 4th? It's positive 16. You use a negative 4 times, you're going to get a positive. Okay, one more type problem and then we're done. Example 5 says 16 y to the negative 8 all to the negative 3/4. You're going to work this in sections. You're going to work the number part and then you're going to work the variable part. Okay? So this is 16 to the negative 3/4 and then y to the negative 8 to the negative 3/4. Just like we just got through doing, you're going to have to write 16 as a power, when the first thing everybody wants to write is 4 squared, right? Well, what's the denominator here? In 4. So is it possible that I could write it as something to the 4th power? It would be better if I could. If I can't, 4 squared will work. But is 16 translate into something to the 4th power? 2 to the 4th. 2 to the 4th times negative 3 to the 4th. And the 4's are going to cancel. So this is 2 to the negative 3 power. What does the negative part of that exponent tell me to do? Move it to the bottom. Okay? Now, what happens here? Multiply those exponents together. What happens when you multiply a negative and a negative? Okay, what's 8 times 3? 24 over 4 is 6. So that is times y to the 6th. Is y to the 6th in the bottom of the fraction or at the top? It's in the top. So this final answer is y to the 6th over 8. $382. I want you to do 2 through 24 even. 30 through 44 even. Look at 44 with me. Please excuse my dear Aunt Sally still applies. What's the P mean? And please excuse my dear Aunt Sally. So simplify inside the parentheses. You have x to the 3rd in the top and x to the negative 1 in the bottom. And what do you need to do with those? Well, what about that negative 1? What does a negative part of an exponent tell you to do? Move it across the line. So this is really x to the 3rd times x to the 1st to the negative 1/4. And then there's a 1 in the bottom. Now what's x to the 3rd times x to the 1st? X to the 4th to the negative 1/4. So then what do? Multiply, and the 4's are going to cancel, and you're going to get x to the negative 1. And we're right back to what does the negative part of the exponent tell me to do? Put it in the bottom. Everybody have that?